Okay, next thing is the electronic speed controller, or ESC, or as it's affectionately known, Speedy. This is what a speed controller, an ESC, a Speedy looks like. I have 2 wires going to my battery, 3 wires going to my motor. That's interesting. You can ask your students about 2 wires and 3 wires, what that means. And I have my basically a servo lead, earth, black, power, red, data, white in this case. It'll go to my receiver. Or if it's a drone, to my flight controller. This is what it looks like in the complete system. It's my electric motor in the front of, or back of my aircraft. You see the 3 wires connected to my motor, 3.5mm bullet connectors. We standardise with those. Here's my speed controller, 40 amp with a BEC. Tell you what the BEC is, the UBEC. And there it is plugging in to my throttle channel. It says throttle there. And get the little satellite out of the way for the moment. I'm going to unplug the satellite. You've done your job. And I've got a servo plugged into my rudder output servo. We talked about PWM on a previous video, on a different video. So that's the complete system. Motor, speed controller, electric motor, not an engine, a motor, electronic speed controller, radio receiver, and servo. You can imagine that there would be a number of servos coming out here, okay? Or this receiver would be plugging in to an autopilot, into the input channels on an autopilot, and the output channels would be going to my speed controller and then to my motors. That'll be another video. But if it was an aircraft, that's what it would look like. It's as simple as that. There's my battery connection there. Okay, positive and negative, just there. So back to the speed controller. I've got a beautiful little piece of equipment. I'm not going to go into the electronics inside because I don't know anything about the electronics inside. I don't care at this stage. I've got DC power coming in from my battery. Okay, from a normal, this is a lithium polymer battery. But it doesn't have to be a LiPo, it could be just an old NiCad battery. It's DC direct current power. Going out though is AC. What this piece of electronics does, it converts DC to AC. Because I need to be able to switch the signal to my electric motor in order to energize the coils so that they interact with the magnets on the inside to drive the motor around. Very, very high frequency. So it's AC. DC comes in, AC comes out. That's my signal. So that's plugged into my receiver. Just there. Plugged in. Get rid of you and I'll go back to this one. Bring my transmitter in here. Did you hear that? That was just a warning from the transmitter saying I had my throttle high, because as a safety feature you don't want to have your throttle high, arm your aircraft. It shouldn't arm anyway, but let's say for argument's sake it did, and you had it up like that, you turned everything on, the aircraft throttles up, it flies into your leg or something. It needs to see, the speed controller actually, the receiver and the speed controller actually need to see a low throttle position in order to arm. It's a safety feature. If it didn't, well, this transmitter does this buzzing, annoying buzzing sound, but also this would not arm until you went low throttle. Its receiver sees that, sends a signal to the speed controller to arm system. Okay, so there's a Speedy. I'm at low throttle. I advance the throttle. The signal is transmitted out, picked up on the receiver. That signal is sent to the speed controller, which will then govern the amount of power flowing from the battery to the motor. It will send the appropriate amount of power to give me half throttle. I want to go faster, command full throttle. That's sent to the receiver. It picks it up. The receiver picks it up, sends a signal to the speedy, which allows full current to flow through to the motor, and it goes full power. I like telling the kids this is like the teacher's voice commanding something. This is like the ears on a person receiving it, passively receiving it, and sending it through the command to like your muscles or something like that. So it receives a passive device. Having said that, you can get some receivers that actually can send data, transmit data back, telemetry, which is data, and then you can pick it up on your screen here. So actually it can be a two-way thing. Mostly it's one way. Okay, so that's your electronic speed control, the main things it does. This is 30 amp. It means the current that this speed controller can handle is 30 amps. This one here is 40 amp. And the current it can handle, sometimes, I've seen motors, the wrong motor speed controller combination. The pilot commands full throttle. The receiver goes, he wants full throttle. The motor's happy, it'll take whatever you give it, but the speedy can't handle it. It might only be a lower amperage rating, like 20 amp, 15 amp, and you'll fry it. Another really, really interesting thing that the speedy does is if you fly your battery to exhaustion, it will disable power to your motor, but keep power going to the receiver and your flight controls, so that you can still dead stick back to the field. You'll still have power. Right, in the old days, you would run out of fuel in your plane or whatever, or run out of battery power to your receiver. It's game over. Your plane won't respond. It'll end up in the next county or somewhere. But these days, safety feature is that I shouldn't run my battery to exhaust. Should run it down to about 30%, no more. Take 70% out of it, but no more than that, really. If I do that, it will still give me power to my receiver and my flight controls. You can program speed controllers too. You can have speed controllers for helicopters, in which case that would be like a slow spool up. You don't, with the lengthen the mass of a helicopter blade. You don't want them suddenly trying to start. Something's going to give in the connections. That's why helicopters have this slow spool up, because there's so much mass. And you can program speed controls to do that. You can program them in different ways, but they are programmable. You can program your speed controller to have a prop brake, so that when you go to low throttle, the propeller, instead of windmilling, which creates more drag, you can get it to brake or stop. It just locks in place, and that's the magnets inside working to lock it in place. Speed control is fundamental to what we do. Everything electric has got an electronic speed controller. They can handle high current, okay, which is the important thing. And by the right speed control. If I was to get a propeller, not like this big bad boy, the wrong size propeller on this motor, obviously this is way too big. Not even electric, but if I put the wrong size propeller on this, the motor's going to be quite happy. It says, yeah, right. Actually, that's not exactly true. But it'll try to do its best. And the speed controller, to turn that huge propeller, is going to command lots of current from the battery. The battery will try to deliver it. The speedy, it will exceed the current rating, and you'll fry it. And or fry your motor, but it'll probably be the speedy that goes first. So you've got to match your propeller to the speed controller. And when you buy your motor, it'll tell you the right size speed controller. It'll tell you the right size, what battery it's for. Okay. Speed controller, wonderful piece of equipment. This is for a brushless motor. If it was a brush motor, it would be missing one. It would just have DC in, DC out. But this is what we mostly use these days, especially on our drones, is a brushless motor speed controller. One thing I didn't mention was this has got a BEC in it. It's a UBEC in this case. BEC is battery elimination circuit. And what's happening is I got 12 volts for my normal lithium polymer battery, about 12 volts coming in here, 12 volts going out to my motor to supply a lot of current. But my receiver, as I mentioned on another video, can only handle 5 volts. What the UBEC does, battery elimination circuit, it eliminates the need to put a separate battery on here to power my receiver. Yes, I used this when I was binding, but then I put it away. I wouldn't need it again because my UBEC through my speed controller is supplying 5 volts to my battery. Even though there's 12 volts coming in to the system, there's only 5 volts going out there. Be careful, some speed controllers don't have a BEC. It'll say that. You'll need to power your receiver separately. Okay. Some people decide to put a battery on here just as a redundant thing, just in case this fries, just to keep their receiver powered, but I never do. Completely confident in this system. Speed controllers.